We have just shown that the derivative of an exponential function is equal to the function e to x itself. This can be visualized graphically if you consider the exponential function and the derivative which is the same function. Then you see at x is 0, the function value is 1, and not just the function value, also the slope of the tangent is equal to 1. If you go to the right, then the function values increase, and so does the slope of the tangent to very, very high values. So the derivative goes up. If you go to the left, then the function approaches 0, and at these points, the tangent is almost horizontal, almost the same as the x-line, so the slope is almost 0, the derivative is very small. Now, what about an exponential function with some base different from e, say 2 to x? We can always write 2 to x as e to logarithm of 2 to x. But logarithm of 2 to x can be written as x times logarithm of 2. So 2 to x can be written as e to x times logarithm of 2. And the derivative is the derivative of the exponential function with the base e, which is here, is the function itself. But this is a composed function, so we must multiply by the derivative of the inner function. And the inner function is just x multiplied by a constant. But x multiplied by a constant derivative is the multiplicative constant itself. So we must multiply by logarithm of 2. And this can be simplified because this term is just the function itself, 2 to x. So the result is that the exponential function and its derivative is the function itself times the logarithm of the base. This was for the base 2, but for any base, let's call it a, the derivative of a to the power of x is the function itself times the logarithm of the base. Is it in agreement with this result? It looks different. We multiply by something. There is no multiplication here. But if the base a is equal to e, then what we multiply by logarithm of a is just logarithm of e, but the logarithm of e is 1. So we multiply by 1. So if a is e to x, the derivative is just e to x. For the base to be slightly less than e is 2.7 something, 2 is slightly less. The logarithm is positive, but slightly less than 1. So it doesn't grow so fast as with the base e. If we have the base greater than e, like that, then the derivative is again the exponential function times the natural logarithm of 10, which is more than 1. So this increases faster than e to x alone. And if a is between 0 and 1, then the logarithm is negative. the derivative is negative, and this is in agreement with the fact that the function, exponential function, is decreasing for low base. The exponential function looks like that. Say if we have 1/2 to the power of x.